Alrighty, so today we are looking at how to compose two functions. The composition of functions just means you're taking one function and plugging it into another and simplifying as best you can, maybe evaluating if it asks you to plug in a number after you plug in a function. But for starters, we're just taking one function and plugging it into another. So that's what composition of functions is. First off, f of g of x equals f of x of g of x. That's literally how it's said, f of g of x, okay? This little circle, the f of g, it's different from this, right? This is multiplying. This is composition, or composing, okay? So what it means is we take g and we plug it in to f, okay? The best way to figure this out is to kind of just go for it. So in my first two examples, it says if f of x is 2x plus 7 and g of x is 4x plus 1, find each of the following. Number one is just f of g of x. So something to remember here is order matters, okay? Order matters. Very important, okay? Box it, squiggle it, whatever. Order matters. So we want to make sure we remember that, okay? Highlight it, whatever works, guys. Just make sure you know that order matters. Okay, so I'm going to use, let's use blue for f of x, and then g of x will be red, okay? So I have f of x is 2x plus 7, g of x is 4x plus 1. Example 1 asks me to find f of g of x. F is the first letter. So f is the first function that I'm going to write down, okay? So I have f of x equals 2x plus 7. Then the second function, the second letter we see is g. G is here. So I'm going to take g, I'm going to plug it in to every place I see an x, okay? Now remember, f of x is the name, okay? The name is the name is the name is the name. It's not going to change, so I need to make sure I keep my name. I'm going to plug g in, though. F of, instead of x, I have g of x. Okay. On this other side, though, I have 2x plus 7, but instead of x, I'm plugging in what g is. G is 4x plus 1. Okay, I'm actually going to go ahead and change this color right here because I didn't think about that. G of x. Okay, so just as a reminder, this is the name, guys. This won't change, okay? It's the name, it's the name, it's the name. So I'm going to be continuously writing f of g of x along the left side. On the right side is where I'll, show all my work, all my steps, all my simplifying, but the left side's going to stay the same from here on out, okay? So I have f of g of x equals 8x plus 2 plus 7. From here, I'm just going to combine my like terms, and I have f of g of x equals 8x plus 9. Now, some of you might be wondering, well, what are we supposed to do? Oops. Highlight. What am I supposed to do with this x right here? Okay, all that x means is you're leaving the x's there if there are any, right? You're leaving this x alone. You're not plugging anything in after this, okay? That means that this is your last step. You don't have to worry about it. You can just leave it as is, okay? Now, if there was a number in here, like if this was a number, well, then I'd have to plug it in. But it's not, so I don't. That's basically it. This is my answer. Okay, now we're going to move on. Just for convenience sake, I'm going to rewrite my functions down here as well. And I'm going to erase this weird line. And if you can hear really loud breathing, that's Norman. He's taking a nap and his nose is smushed into the couch. So if you can hear really loud breathing, that's what that is. Don't be alarmed. F of x is 2x plus 7. G of x is 4x plus 1. Okay? We're going to go ahead and look at our order. G is first, so I'm going to write that down first. G of x equals 4x plus 1. Then I'm going to take f of x and I'm going to plug it in here and here. Okay, so I have G of f of x. Oops. Let me erase this really quick. Worry about my parentheses first. Okay, so I'm going to plug in f of x. I'm going to plug in the actual name here, and then I'm going to plug in what it is, 2x plus 7, right there. Okay, and then I'm going to work through my steps. G of x, G of f of x, goodness, equals 8x plus 28 plus 1. Then I'm just going to worry about combining my like terms, which are there. And I have G of f of x equals 8x plus 29. Okay, as long as you guys follow these same exact steps that I'm using and you don't try and switch it up or skip any steps, you should be good to go. Like, it's literally just this process over and over and over. Just don't skip any steps and you should be fine. So we're going to move on to the next set of examples. F of x equals 2x minus 5 and g of x equals 6x minus 2. Okay, again, the order matters here. In example 1, I'm asked to find f of g of negative 3. So if you notice here, I have this negative 3 that I am going to have to plug in eventually, but I'm not going to worry about it to start. All I'm going to worry about is figuring out what f of g of x is. So what I'm going to do is I'm going to put f of x in blue again, g of x will be in red again, and we're going to go for it. So I have f of x equals 2x minus 5, and I'm going to plug in g of x here and here. So I have my equation with my parentheses, and I'm going to plug in my function. Okay, so I'm going to go ahead and rewrite my name, f of g of x, and it equals 2 times 6 is 12, so 12x. 2 times negative 2 is negative 4, and then I have the negative 5 at the end. Going to combine my like terms so that f of g of x equals 12x minus 9. Now what I have to remember, I cannot forget, guys, I have this negative 3 that I'm going to have to plug in here and here. So this is going to become f of g of negative 3. I'm just going to go ahead and write my little parentheses. And I'm going to plug in my negative 3. So I have f of g equals 12 times negative 3, that's negative 36 minus 9. Negative 36 minus 9 is going to be negative 45. Okay, so when we plug in these numbers to evaluate, we do get an actual full number answer, meaning we're not left with any variables. Okay, so we're going to move on to our next example. It asks for g of f of 2, but again, I'm just going to worry about g and then plugging in f, simplifying as best I can, and then plugging in the 2. So g, we're going to start there. G of x is 6x minus 2. I'm going to plug in my f value. So I have g, and I'm going to plug in f. F of x here, and what f actually is, which is 2x minus 5. I'm going to distribute, and I'm going to rewrite this name. 6 times 2 is 12, so I have 12x minus 30 minus 2. I'm going to go ahead and combine my like terms. G of f of x equals 12x minus 32. Again, I have to remember that I have this 2 here that I have to plug in here and here. So I have g of f. I'm going to plug in a negative 2 there, or a positive 2 there, and a positive 2 here in like half a second. So 2, 2. So g of f of 2 equals 12 times 2 is 24. 24 minus 32 is going to be negative 8. Alright, I'm just trying to separate all of this a little bit, so maybe it's easier to chunk. Okay, so we're moving on to example 3. I have f of 1/2. So, oh my goodness, fractions, but guys, we'll be fine, okay? F of f. Do you see any g's anywhere? If you answered no, great. We don't see any g's, so I'm not going to use any g's. What I'm going to do is I'm going to write f down. F of x is 2x minus 5. Then I'm going to just make room, just like I always have. And what am I going to plug in? Well, I'm going to plug in f. That's what it tells me to do. It tells me to write it down and then plug it in. So I'm going to. This is f of x. And this is 2x minus 5. I'm going to distribute just like I always have. And I'm going to combine like terms. Nothing new. Then I'm going to remember, oh goodness, guys, we have a fraction. It's got to go here. It's got to go there. We got to simplify. It's going to be okay. If I can get rid of the highlighter, it will be okay. Other than that, mass panic. So I have f of 1/2. Okay, so I have 4 times 1/2, and I'm subtracting 15. Now you can do this in your calculator. You can do 4 times 1/2, 4 times 0.5, you know, whatever you need to do here. But don't get caught up in the fact that it's a fraction, guys. It's going to come out to be 4 times 1/2 becomes 4 over 2, and 4 divided by 2 is 2, guys. It's not that big a deal, okay? So I have f of 1/2 equals 4 times 1/2 is 2 minus 15, which is negative 13. Wasn't that bad. Okay, I'm going to divide this up again, and then we're going to look at our last example. Look at us doing big things, guys. All right, our last example is g of 3/4, 3/4, however you want to say it. Okay, g of g means there's no f, means I'm not going to worry about f at all. It doesn't exist as far as I'm concerned. What I am going to worry about, though, is writing g down. Okay, so I have g of x equals 6x minus 2. Okay, now I'm just going to rewrite it. I'm going to give myself a little more room. And I'm going to plug g right back in. So g of x is 6x minus 2. From here, guys, we distribute. G of x equals 6 times 6 is 36. Again, I'm just going to make my g's look like g's because it's throwing me off, so maybe it threw you off too, I don't know. 6 times 6 is 36. 36x minus 6 times 2 is 12 minus 2. And then I'm going to combine my like terms. G of x equals 36x minus 24. What the heck? 14. 14 sounds a lot better. Let's go with that. Alright, so before we're done, though, we still have to remember that, hey, there's this little fraction, and it's got to go here, and it's got to go there, and we're going to do that. So I'm going to rewrite this as g of 3/4 equals 36 times 3/4 minus 14. Okay, guys, take your calculator, type in 3 divided by 4. What do you get? 0.75. So then take 0.75 and multiply it by 36. And I'll even do it with you. What do you get? 27. Great. So g of 3/4 equals 27 minus 14. Okay, 27 minus 14 is going to be 13. Except in this case, it's positive. All right. We have our last answer. And we are done. That is how you compose two functions and evaluate two functions after you compose them.